Hi everyone, welcome back. And I understand it's too much theory, but sometimes it's good to learn theory as well. Okay, let's continue our OSI model, and this time it's network layer, which is layer 3. Okay, so first physical layer is done, then after that we had data link layer, then the network layer. It handles routing of data packets across different networks and ensures that data is delivered to the correct destination. So the information is already gone from your device system. Now it's in network. It deals with the logical addressing and routing. Logical addressing, it means, for example, IP address, routing and packet forwarding. The network layer determines the best physical path for data to take from the source to the destination. This involves selecting the most efficient route based on factors like network topology, traffic conditions, and link quality. Routers operate at this layer using routing protocol, for example OSPF, BGP, to make forwarding decisions and to exchange routing information with other routers. Uses logical address, typically IP address, like I said, IPv4 or IPv6, and these addresses uniquely identify devices on a network and are used to route packets across different networks. So for example, the destination is of course having an IP address, right? To which IP address that information the data should flow. IP addressing allow for the identification of device over vast interconnected networks like the internet. So like if it is internet based application, that using that IP address the information will flow. Okay, the data is encapsulated into packets at the network layer. Okay, so in previous one it was in the data link layer. The similar way, we created frames. Here also the data will be encapsulated into packets. These packets contain not only the payload but also headers with the important information like source and destination IP addresses, which are used to guide the packet through the network. The network layer is responsible for forwarding these packets from one router to another until they reach their final destination. Sometimes the data packets needs to be split into smaller fragments to fit into the transmission constraints of the network. So for example, if the data packet size is too high, so first we will split it, make it smaller packets, and then those packets will be transferred over the network. The network layer handles the fragmentation of packets and ensure that they are reassembled correctly at the destination. So these fragments, for example, if it is a bigger packet, right, we'll just first split them, and those split ones are called fragments. So for example, if there is one, we split it into 5, the 5 will be transferred on the over the network, and then on the destination side again those will be collected, reassembled to make it one single packet. That is how it is. The network layer is also responsible for handling and reporting errors that occur in the transmission process. Protocols like ICMP, Internet Control Message Protocol, are used for sending error messages and diagnostic information. Okay, what protocols we used at layer 3? One is the Internet Protocol, which are IPv4 or IPv6. ICMP protocol, this is used for error messages and network diagnostics. IGMP, Internet Group Management Protocol, used for managing multicast groups. Routing protocols, so for example OSPF, Open Shortest Path First, BGP, Border Gateway Protocol, AIGRP, Enhanced Interior Gateway Routing Protocol. I know it's bit theory, but it is good to understand. And if you are really looking for, or if you are already having career in the networking, then anyways you will encounter these protocols more often. Okay, now let's understand the use cases, because if you understand the use case, right, it is easy to no need to even memorize. It is easy to understand the whole concept of networking layer. Use case, you want to access a website hosted on a server in another country. Simple use case, and we do it regularly. So how layer 3 will work? Whenever we'll type the website URL into the browser, and the request is converted into series of packets with the destination IP address of the website server. So when we are seeing packet, whenever we will input the URLs, for example, it's www.google.com. It's not that the whole Google website, how this whole transmission is happening. So the first, my request will be converted into smaller packets. So if you are already aware of it actually start a bit 0 or 1, and with 0 and 1 we will create the whole data. So first we will create the packet, and then that packet, actually the information will flow to the IP address of that server. I mean, though we just write it google.com, but behind the scene it's a server IP address. Routers at various point in the network, such as your local router, ISP router, or backbone router, how many routers you have, use layer 3 protocol to determine the best path for these packets to travel across multiple network. For example, your home network or Wi-Fi, your ISP network, etc., to reach the server. I mean, how you are going to connect to the internet. Each router examine the destination IP address in the packet header and forward the packet to the next router along the selected path until it reaches the server hosting the website. Simple. This is one of the example, routing. I mean, whenever you hit the website in your browser, the packet will be converted. We will have the router in place, whether it's home network or any you are using Wi-Fi of maybe your home office, etc. And using that router, the destination IP will be examined, and then the request will be flown. The packet will have this header, etc., the IP address, etc., and then finally the server hosting the website will be reached, and then it will serve the request. Now next example, I mentioned logical addressing. What is that logical addressing? Two devices on different networks need to communicate. Two different devices. Device A has the IP address, for example this one, on network A. Device B has the IP address this on network B. Network A is it's my Wi-Fi. Network B is maybe your Wi-Fi, your office Wi-Fi. Okay. Layer 3 ensures that when device A sends message to device B, the packet is addressed to B's IP address. Routers use these IP addresses to forward the packet from network A to network B, and it makes sense also, right? So router installed at this location at network A, right, will forward the information to another router which is installed on network B. That is what is written here. Without layer 3 and IP addressing, communication across different network would not be possible. See, it's simple. Wherever we will have the network, right, router is nothing but just consider a person is sitting and just doing job for you. Whenever you communicate, you want to communicate to another device or over the web, right? This person's job is to see what is the IP address you want to interact with and then communicate with the other guy. Okay, then packet forwarding example. Use cases, I just want to send an email to a friend. Okay, when we send the email client breaks the email data into smaller packets. Email client is, for example, my Gmail, etc., right? So smaller packets, each packet is given the IP address of the destination mail server, of course. So for example, I'm writing hi friend. The hi friend, that one single email will be converted into several packets, and each packet will have the IP address. Just consider if one of the packet is not having IP address, maybe instead of hello friend, it's just hello and then FRIE is gone, just ending. So it's very annoying, and then but yeah, that's why each packet should have the IP address. These packets are forwarded by routers across the internet. So this brother, right, the router brother is always available for our help. So each router using the layer 3 information like IP address to decide whether to send the packet, where to send the package next. So good thing is the all packets are having IP address, and brother router, he will just see the IP address, will send that packet to that router. It's just a kind of mail boy. You just need to on each envelope you need to specify the address, and the courier boy will just see the address, will deliver it to that door. That's it. Eventually all the packets reach the destination mail server where they are reassembled again into the original email. Simple. This is interesting. I mean, how many packets you are creating, and each packet will have the start and end trail. When at the receiver end, using that information in the header, all the packets will be reassembled, and finally we will have just one chunk of email. Okay, another one, this fragmentation and reassemble example, the transmitting a large file over the network. So we already covered it while we use that example, the email example. But again, suppose the network you are using has a maximum transmission unit size of 1500 bytes, but your file size is maybe 3000 bytes. It's bigger. So what will happen? Layer 3 will first fragment this packet into two smaller packets that fit within the MTU limit. Yeah, so I mean, just a big file. Sometimes we do that because of I cannot lift that much weight. So maybe I will first divide the weight. We'll first pick one item, put it on the destination, then second item, put it on the destination, and then I will reassemble it to make it one. That happens even with normal daily logistics. We do that. These fragments are sent individually over the network and reassembled back into the original packet by the destination device. So if we notice overall what is happening, so over the network we have a source, we have a sender, we have a receiver, both sides we have router. For information flow we have packets, and then we create fragments of those packets. Each fragment will have the IP address, and then on receiver side those fragments will be first reassembled into packets, and then finally the whole information will be received by the destination. This is what is happening in overall. That's it in this video. Thank you so much for watching.